The RPM Package Manager, originally known as Red Hat Package Manager, is an open-source package management system used primarily in Linux distributions. The term RPM refers to both the .rpm file format and the Package Manager application itself. Initially developed for Red Hat Linux, RPM has expanded its usage to various other Linux distributions, including Fedora Linux, CentOS, OpenSUSE, and others. Furthermore, it has been adapted to different operating systems like Novell NetWare, IBM's AIX and I, as well as Arca OS. Within an RPM package, there can be a diverse collection of files. Binary RPMs, BRPMs, typically consist of compiled software versions, while source RPMs, SRPMs, include the source code necessary to construct a binary package. SRPMs are identified with a distinct tag in the file header, setting them apart from regular RPMs and leading to their extraction to USR upon installation. In some instances, SRPMs may bear the file extension .sarc.rpm or .spm in file systems limited to 3-character extensions. RPM, created in 1997 by Eric Troan and Mark Ewing, builds upon prior experiences with package management systems such as PMS, RPP, and PM. The roots of RPM can be traced back to PM, developed by Rick Faith and Doug Hoffman in May 1995 for Red Hat software, which drew inspiration from PMS, originally crafted by Faith and Kevin Martin for the bogus Linux distribution in the fall of 1993. RPM retains the core concept of pristine sources plus patches from PMS, but enhances it by removing limitations and introducing new functionalities. Notably, RPM boasts robust database support that greatly facilitates package tracking and validation upon installation. For system administrators overseeing software deployment and upkeep, opting for package management over manual building brings forth a host of benefits, including streamlined processes, uniformity, and the capacity for automation and non-interactive execution. Although RPM traditionally relied on Berkeley DB as its back-end database, starting from version 4.15 released in 2019, it offers the option to construct RPM packages without Berkeley DB through the use of the disable BDB flag. Moreover, RPM encompasses various features, such as the ability to perform cryptographic verification using GPG and MD5, inclusion of original source archives in SRPMs for simplified verification, support for Delta updates via patch RPMs and Delta RPMs akin to patch files for incremental software updates, and automatic evaluation of build time dependencies. Packages within a particular distribution, such as Red Hat Enterprise Linux, or those built by external parties like RPM Fusion for Fedora Linux, may lead to circular dependencies among RPMs, known as dependency hell, requiring a comprehensive installation command. RPMs are commonly stored in repositories on the Internet or within local mirror repositories or locally curated RPM collections on a site. Front-end tools like Yum in Fedora Linux, CentOS, Red Hat Enterprise Linux, Scientific Linux, Yellow Dog Linux, Oracle Linux, and DNF in Fedora 18 and newer versions aid in fetching and installing RPMs from repositories while managing dependencies. Other front-ends like UpToDate, Zypper, URPI, apt-RPM, Smart Package Manager, RPM Query, and libzippy also streamline the RPM handling process across various Linux distributions. The RPM database, residing in chupafar-lib RPM and utilizing Berkeley DB, serves as the backbone of the package manager. It comprises a primary database, packages, housing metadata of all installed RPMs and multiple index databases for accelerating queries. This database tracks modifications and creations of files during package installations, enabling users to later revert changes or uninstall the package through RPM. In cases where the database faces corruption due to factors like RPM client termination, the index databases can be regenerated using the RPM rebuildb command. Across various Linux distributions, the RPM format remains consistent, but specific conventions and guidelines can differ. An RPM is typically found as a single file, with a file name structured as follows: name version release.sc.rpm for source packages, or name version release.architecture.rpm for binaries. For instance, in a package like libnumwim checkn 2.0 2.0.3 to i386.rpm, the name would be libnumwim version 2.0, release 2.0203, and architecture i386. Notably, RPMs labeled as noarch.rpm are independent of CPU architecture and may include graphics, text, shell scripts, or programs in interpreted languages like Python. The package label of an RPM incorporates information such as software name, version derived from the original software source, release number indicating rebuilds, distribution specifics denoted by tags like MDV, Mandriva Linux, and architecture, e.g. i386 x8664. When it comes to library packaging, versions are split into two packages, one with precompiled code for runtime use and another with development files like headers, distinguished by adding devil to the name. System administrators should confirm compatibility between binary and development packages. The RPM format itself is binary, comprising the lead marking it as an RPM file, a signature for integrity, a header with metadata, and a file archive in CPIO format compressed with gzip. While the Linux standard base mandates gzip, Fedora 30 opts for XZ compression, with Fedora 31 potentially moving to ZSTD. Newer RPM versions can utilize bzip2, lzip, or LZMA compression, with RPM 5.0 supporting XAR for archiving. The recipe for creating an RPM package lies in the spec file ending with .spec, detailing the package name, version, build steps, and changelog. Multiple packages can originate from one RPM spec file. The creation of RPM packages from spec files is facilitated by the RPM build tool, commonly shared in SRPM files containing both the spec file and source code. An SRPM accompanying precompiled RPMs enables users to compile and customize the code. Conversely, an SRPM without source, known as no SRC, includes the spec file and possibly patches, but lacks sources, often due to licensing constraints. By June 2010, two RPM versions were being developed, one by the Fedora project and Red Hat, and another by a group led by a former maintainer of RPM, who was previously employed at Red Hat. The rpm.org community underwent its first significant code revision in July 2007, with subsequent releases version 4.13 in July 2015. Distributions like Fedora Linux, Red Hat Enterprise Linux, OpenSUSE, SUSE Linux Enterprise, Unity Linux, Mageia, Open Embedded Tizen, and Open Mandriva LX, previously Mandriva, utilize this version. RPM version 5, spearheaded by Jeff Johnson, the RPM maintainer as of 1999, and contributors from various distributions, was introduced in May 2007. RPM 5 was employed by Wind River Linux until Wind River Linux 10, Rosa Linux, Open Mandriva LX, previously Mandriva Linux, which transitioned to RPM 5 in 2011, and the OpenPKG project offering packages for multiple Unix platforms. Open Mandriva LX switched back to rpm.org during the 4.0 release, while Open Embedded, one of the primary RPM 5 users, reverted to rpm.org due to concerns with RPM 5 functionality.